Okay, here we have question 10 from November 2016. It says the flow diagram below shows the processes involved in the industrial preparation of fertilizer Q. So now whenever you get one of these flow diagrams, you should try and figure out what's going on in your own head before you start. What actually is fertilizer Q? So here I've got nitrogen plus hydrogen. We're obviously going to make ammonia. And this is obviously the Haber process. This is the most obvious thing. Now on the other side, we're starting here. Check the direction. The arrows are going this way. Okay, so let's go to the starting point. The starting point is sulfur dioxide plus oxygen. So we know we're going to end up here. If we start with sulfur dioxide and oxygen, this must be the contact process. And we should be ending up with sulfuric acid at the end of the contact process. So if we mix ammonia and sulfuric acid, we should end up with ammonium sulfate. Okay, so before you do anything, try and figure out what's going on with the little flow diagram. Now it says to you, what is the name of process X? That's nitrogen plus hydrogen gives you ammonia. That is the Haber process. Now it says to you, what is the name of process Y? So in this question I'm a little bit unclear because here is process Y, okay? So the whole process is the contact process, but if they mean what actually is just this reaction here, okay, then that is the catalytic oxidation of sulfur dioxide, okay? So I'm not 100% sure, do they mean the whole process or just this process? But either way, you could possibly put both answers. I checked the memo. The memo actually accepts both answers, and they put the contact process first. So presumably then they mean the whole process. Then it says to you the name or formula of gas P. This is gas P over here, and that is SO3 or sulfur trioxide. Okay. Then it says to you the balanced equation for the formation of fertilizer Q. Well, we already decided that fertilizer Q is ammonium sulfate. We decided that we were making ammonia and sulfuric acid. So 1 mark for your reactants. Then you show that they are reactants by putting the arrow. And my final product is ammonium sulfate. Now remember, the sulfate ion is 2 minus, the ammonium ion is 1 plus. The compound must be neutral, so I need 2 of those to make ammonium sulfate a neutral ionic compound. And now if you have a look here at my nitrogens on this side, I need to make this 2 ammonias to balance it, and then everything else is balanced. Okay, then it says to you here, the diagram shows a bag of NPK fertilizer of which the NPK ratio is unknown. It's found that the mass of nitrogen in the bag is 4,11 kilograms. Okay. Then it says to you the mass of phosphorus is 0,51 kilograms. Calculate the NPK ratio. Well, the first thing to remember is, remember, this 36 over here says to you only 36% of the mass of the bag, which is this 20 kilos over here, only 36% of the 20 kilos is actually fertilizer. So 36% of 20 kilos, if you use your calculator, you end up with 7,2 kilograms of fertilizer. So now this fertilizer has to be the N, the P, and the K. So 4,11, the N, plus the P, plus the K is equal to your total fertilizer. Okay. So then here is my N is 4,11, my P is 0,51, and my K is what I'm trying to find out, and this adds up to 7,2 kilograms. So what is my mass of K going to be? It's going to be 7,2 minus these 2, which is 2,58. Please check on your calculator. Okay, so now we want the NPK ratio. So what is the N was 4,11 the P was 0,51 and the K was 2,58. So we're going to divide by the smallest, which is 0,51. So 0,51 divided by 0,51 automatically becomes 1. If you put this in your calculator, you get 5,05. And if you put this 4,11 divided by 0,51 in your calculator, you get 8,05. And then we usually simplify it is to 8, is to 1, is to 5. And this is my NPK ratio. 8 is to 1 is to 5.